Hi, my name is David Judd, and I'm a TSA with the Nordine Technical Services Department. And for today's Lunch and Learn presentation, we're going to be going over some of the more common calls that we get in tech services regarding our high-efficiency G7 single-stage and two-stage gas furnaces. Anytime during today's Lunch and Learn presentation, if you have a question, you can submit it to the box to the left of your screen. Our topics today are going to include pressure switches, low voltage wiring, the limit circuit, vent piping, and broad ocean motor testers. So let's start with pressure switches. All of our 90% single stage and two stage G7 gas furnaces have at least two pressure switches. We have a vent pressure switch and a condensate pressure switch. The vent pressure switch is there to monitor the negative pressure that is produced within the vent piping system and the inducer motor housing. If the pressure in the vent piping system drops below the rated opening pressure on the switch due to a clogged PVC pipe, then the pressure switch will open. The condensate pressure switch is there to monitor the negative pressure produced within the secondary heat exchanger. If water should become suspended inside the secondary heat exchanger or a condensate drain should become clogged, the condensate pressure switch will open up and shut down operations. Our 92% and 95% single stage gas furnaces have two pressure switches. We have a condensate pressure switch and a vent pressure switch wired in series on the two orange wires that go back and connect to the 9-pin Molex plug to the control board. A two-stage G7 95% gas furnace has four pressure switches. We have a low-fire condensate pressure switch and a low-fire vent pressure switch. These two pressure switches are wired in series on the two orange wires that go back and connect to the 12-pin plug at the interface control board. We also have a high-fire condensate pressure switch. We have a high-fire vent pressure switch. These two pressure switches are wired in series on the violet wire that goes back to the 12-pin Molex plug that connects to the interface control board. All pressure switches are normally open switches. That is, when the inducer motor is off, the pressure switches need to be in open position. For a furnace cycle to start, the interface control board needs to see this open circuit. On a call for heat, the inducer motor will start and the pressure switches must close within 10 seconds and remain closed throughout the entire heating sequence. If a pressure switch opens during the heating process, the board will drop out flames and the furnace will shut down as if you lost a call for heat without flashing a code on the interface board. The furnace will then attempt to refire by starting the inducer motor up and attempt to close a pressure switch. If the pressure switch does not close at that time, the control board will give a flash indicating an open pressure switch. Many times, a blocked condensate line or a blocked flue pipe or undersized flue piping will cause your pressure switch to open and shut down furnace operations. One of the easiest ways to test to see if a pressure switch is open or closed is by checking for voltage across the switch. When the inducer motor is running, take a voltage reading across your switch. You should read 0 volts. That would indicate the pressure switch is closed. If the inducer motor is running and you measure 24 volts across the switch, then the switch is open. Our next topic we're going to cover is a low voltage wiring circuit. Our low voltage wiring is what connects our thermostat to our interface control board. We also refer to this as our control wiring. Our control wiring connects at our interface control board on the terminal strip. It then runs through the thermostat wiring and connects to the thermostat. Our control board sends 24 volts from the R terminal on the control board to the R terminal on your thermostat. Your thermostat then, on a call for heat, will send 24 volts back to the furnace to the W terminal to initiate a call for heat. Remember, a thermostat is nothing more than a switch. It just sends voltage where it's commanded to. The easiest way to test for this is to turn your thermostat up 2 or 3 degrees on the set point temperature above your room temperature. This will hopefully ensure that your thermostat is calling for heat. At this time, your inducer motor should start and run to start the heating sequence. If your inducer motor is not starting, we need to verify if you have 24 volts at your terminal strip on your control board between the common terminal and the W terminal. If you do not have 24 volts between common and W, we need to verify 24 volts between the common terminal and the R terminal. If you have 24 volt AC between common and R, but not common between W, that means we are not calling for heat at the interface control board. The problem could be either in your low voltage wiring or in the thermostat itself. Many times, weak batteries in the thermostat will cause the thermostat to not make a call for heat. It's very common to find this problem related to weak batteries. The next topic I would like to discuss is the limit circuit. The limit circuit is there to protect the furnace from running at abnormally high temperatures within the furnace cabinet or within the furnace heat exchanger. All the limit switches in the limit circuit are wired in series on the blue wire that goes back and connects to the control board. This blue wire is powered by 24 volts from your interface control board. Our limit switches, we're going to have a main air temperature limit, which is a surface mount switch that monitors the temperature within the heat exchanger itself. This is an automatic reset type switch. Down in the blower compartment, we have two limit switches that are mounted to the blower housing. These two switches monitor the temperature in the blower housing area. These switches are also automatic reset type. Our next switch we have is a vent limit switch. This monitors the temperature with an vent piping system. This is a manual reset type switch. If this switch is open, you'll have to press the red button to reset the switch. In our main burner compartment area, we have a flame rollout switch that's mounted below the burner assembly. This is also a manual reset type switch. So if this switch were to open, you'll have to press the red button to reset the switch. The most common cause for limit switches to open is due to low airflow. Low airflow across the furnace cabinet or across the heat exchanger will cause the furnace to run at abnormally high temperatures. Remember, low airflow equals high temperature rise. If we are getting a high temperature rise, we're most likely operating at temperatures that are at or above the set temperature on the switch, causing the switch to open. The easiest way to check a limit switch to see if it's open or closed is to check 24 volts across the switch. If you measure voltage across the switch and measure 0 volts, that tells me the switch is closed. If you measure 24 volts across the switch, that tells me the switch is open. If you find a switch that is open and will not close, never jump the switch out. This can cause the furnace to operate at unsafe conditions, which can damage your furnace or damage your home itself. You must replace the switch. After you replace the switch, make sure and start the furnace up and test it to see if it's operating within the temperature limits. When troubleshooting any of the limit circuit, pressure switch circuit, control wiring circuit, don't get too wrapped up in all the wires within your furnace. Just focus on the circuit that is giving you the problems. If it's a limit circuit, it's going to be the blue wire. If it's your pressure switch, it's either going to be the purple wire or the orange wire. And if it's your control wiring, it's going to be attached at your control board at the terminal strips going to your thermostat. By doing this, we'll help you to quickly troubleshoot the furnace and prevent future callbacks on this equipment. The next topic I want to cover is vent piping. We get many calls in tech services regarding vent piping that results in pressure switches opening up. It's very important to familiarize yourself in our installation instructions that have vent tables that reference our pipe lengths. This vent table will show you the maximum allowable pipe in relation to the BTU input rate of the furnace. Too many times we discover the PVC piping was too small given the BTU input rate of the furnace, therefore it becomes necessary to remove the 2-inch piping and replace it with 3-inch piping. If the PVC piping is too small or the linear length is too long or too many elbows or in the vent piping system, this will cause your pressure switches to either open during operation or not close at all. When you're sizing your PVC piping and you're considering using 2-inch, keep in mind your total length of your pipe plus all of your elbows. If this adds up that you're getting close to the maximum allowable length listed in the vent tables, then I would suggest that you not use 2-inch and just go ahead and upsize to 3-inch. This will help you to eliminate problems down the road relating to pressure switch issues. As a rule of thumb, any furnace over 80,000 BTU, I would always use 3-inch instead of 2-inch. For my final topic, I would like to talk about the broad ocean motor. We get a lot of calls in tech services with contractors wondering if it's the motor or if it's the board. They can't really tell which one it is. There's generally two fault codes that we can choose from. One of the fault codes is a communications fault, which is indicated on the motor board, and the motor fault, which is indicated on the motor board and the interface control board. If you're getting a communications fault, this generally indicates the motor board is bad. The one thing to check for is connections between the motor board and the main control board. These two boards are connected at the expansion port connection on the interface control board and down at the motor control board. You will want to make sure that your connection is good and tight in both places. You can also ohm from plug to plug, and you can ohm from wire to wire to make sure that we don't have a shorted circuit. If your connections are good, and you don't have any shorted wires, and you're getting a communications fault, then I would advise to just go ahead and replace the motor control board. If you're getting a motor fault code indicated on the main control board and at the motor control board, this indicates a problem is most likely in the motor. The only true way to tell if it's in the motor or the board is with the use of a broad ocean motor tester. With the broad ocean motor tester, we can isolate the motor from the furnace and operate the motor independently through the motor tester. The broad ocean motor tester will come with several different adaptable plugs to attach to whatever motor we're troubleshooting. You'll simply pick your adaptable plug that matches your motor and connect that plug to the broad ocean motor tester. You'll plug the adapter plug into the broad ocean motor tester here, and then we need to supply the broad ocean motor tester with 24 volts. We can do that at the motor control board. Test your common to the common connection. Connect your 24 volt to the R connection. We now unplug the motor from the motor control board and plug the motor into our broad ocean motor tester. Now the broad ocean motor tester has power, and we can operate the motor on low speed and high speed to determine if the motor is bad or if your motor board is bad. If I turn on the power, the broad ocean motor identifies this as a 1/2 horsepower motor, and my motor did come on. I can now cycle the motor up to high speed with my tester. Back down to low, and then cycle it to off. If I was getting a motor fault on either one of these two boards, and I tested and proved the motor would come on with my tester, that tells me the motor board is bad. If I was getting a motor fault, and I could not run my motor with my broad ocean motor tester, then that would indeed prove that the motor is bad, and I'd have to replace the motor. Thank you for joining us for today's Lunch and Learn presentation. We just wanted to kind of go over some of the more common questions that we get in tech services regarding high-efficient gas furnaces. We wanted to cover the pressure switches, the low-voltage wiring, the limit circuit, vent piping, and the broad ocean motor. Continue to submit your questions to the box to the left of the screen, and we will now be answering your questions.
Well, we hope you've enjoyed our top 5 furnace tips that we put out today. We got those tips really from all the call tickets from our ticketing system, and came up with that list of top 5 troubleshooting calls that we get into technical service. David wasn't able to join us today. He's out under the weather, so we'll go ahead and answer your questions now. Remember, if you have any questions, click on the left-hand side of the screen and submit your question. And we'll start out with Maria. What color wires are used for the high and low pressure switches? Well, depending on what type of furnace, on our single stage gas furnaces, the orange wires coming from the IFC board go to either, if it's an 80%, to the vent pressure switch, or if it's a 90%, it goes to the vent pressure switch and then down through the condensate pressure switch. Those are all orange wires. The board will send 24 volts out through the pressure switch circuit, and then that board looks for, after sequence of operation, you get a call for heat, the inducer starts, and then you have to close those pressure switches within 10 seconds. Once the pressure switch is closed, that board after that 10-second period of time will look for that 24 volts back. On our two-stage gas furnaces, there are two sets of pressure switch wires. Our low pressure switches, again, are wired in series on the orange wires. And then our high pressure switches are wired in series with one another on the two purple wires coming out of the board. So it's consistent throughout all the product. Our pressure switches on single stage equipment are always orange, and on two-stage equipment they're always orange and purple. Next question is Stuart with Stewart's Heating and Air. When will there be a true LP gas furnace? Well, one of the things with gas furnaces is they always come natural gas, and that's because that's the biggest selling gas type of furnace out there. So we always ship them out with natural. Now, if you are doing an LP job, go ahead and order an LP kit. I don't know the part numbers right off the top of my head, but if you look in the technical specifications for the furnace or in the install instructions for the furnace, those kit numbers are listed in there. If you can't find it either way there, give us a call in tech service. Give our parts guys a call, and they can get that part number, LP kit part number for you. Next question is Barry with RE Michael. Do you know the Broad Ocean motor tester part number? Right off the top of my head, I do not know what it is. Barry, I would ask you if you can, I believe at the end of the question and answer period here, my email address will be flashed up there. Shoot me an email, I'll get you that part number for you. But the Broad Ocean motor tester, we came out with that a few years ago, and it eliminated a lot of the guesswork that we had going on between the furnace blower board and the motor itself. Those are DC PWM communicating motors, so you really can't put, on the low voltage side, you can't put a meter there to troubleshoot or diagnose what a particular problem with a motor might be. So in a lot of cases, and in a lot of instances, we were telling folks to change the motor and board because we couldn't differentiate between the two. Now with the Broad Ocean motor tester, you can connect that tester directly up to the motor, and you can test that motor in low speed and high speed, and if that motor's operating with that tester, the motor's fine. Your issue, if the motor's not running, is going to be with the blower board itself, either the fixed variable speed motor or the true variable speed motor. Next question from Maria. Where are the limits? Are there limits on the blower housing of the gas furnaces? Maria, yes, there are. There are two limit switches on either side of the blower motor. Our limit circuit, remember, as David mentioned in the video, that our limit circuit is all wired in series with one another. It starts out through the heat exchanger limit, down through the rollout limit, through the vent pressure switch or limit switch limit, and then down to the blower limits. There's some furnaces could have a series of 5 limits in there. Those are all wired in series with one another, and I think a lot of guys will forget, especially in a horizontal position, if a motor goes bad or something like that, those limits there are there to protect the furnace and keep the furnace from firing without a blower motor running. A lot of guys will forget, and we get calls on this, you know, maybe a handful of times throughout the winter season, that guys will forget that those limit switches are down there. But those are automatic reset. They're not manual reset. All the other limits within the furnace, except for the heat exchanger, are manual, and you have to push a button to reset it there. I'm getting a lot of great replies on the Broad Ocean motor tester. That motor number is a 921767 is the part number. As I said, it's been out for quite a while, and I know we have sold quite a few of them, and I know they're fairly inexpensive. So I would really encourage the contractors that are watching this or the distributors that are watching this to purchase them and use them. It will be a much easier way to troubleshoot those motors versus the motor and board. So, go ahead and get those ordered up and keep those in stock for the contract or the distributors for the contractors, and for the contractors, go purchase one. As I said, I know they're fairly inexpensive and can help you diagnose the motors fairly quickly. Next question from Dave. What is the purpose of the limit circuit? As I mentioned earlier, the limit circuit is there to protect the furnace from overheating. Now, there are a number of different limits there within our furnace. We'll start out with the heat exchanger limit. Heat exchanger limit is there as stated to protect the heat exchanger from overheating, getting too hot, and possibly damaging some other components within the furnace. All of the limits have their maximum rating, their open rating on the limits themselves. Fairly easy to troubleshoot. Again, the board sends 24 volts out through the circuit. If the circuit is complete, all the limits are closed, it will see that 24 volts coming back. If you've got 24 volts going out on the limit circuit and you measure across to the other side and you're reading, if you're reading 24 volts from one side of the limit circuit to the other side of the limit circuit, that means you've got a limit open. You want to see 0 volts going from one side coming out of the board, the blue wire coming out of the board, to the blue wire coming back into the board. You want to read 0 volts. That would indicate a closed circuit. If you read 24 volts, one of the limits is open. So you start going through each individual limit and finding out which one is stuck open. The heat exchanger limit is an automatic reset. So once a blower cools down the heat exchanger compartment, that limit will reset, fire back up. On the rollout limits, that is a manual reset. If you're getting excessive heat around the burner area, the rollout limit will open up. And that could be low gas pressure, lazy flame hitting up on top of top of the burner area. There's a piece of sheet metal that goes across the top of the burners where that limit's located. Could be bad burners itself, rusted out burners. So check that area, take a look at it, and see if there's any damage there. If you don't really see any damage and your gas pressure is good, check the temperature on the limit itself. I would recommend using a thermocouple type thermometer to read that. Do not use a laser. Remember, laser thermometers are not very accurate. But the only good thing a laser thermometer is good for is just reading the temperature of airflow coming out of registers. Use a thermocouple type thermometer on that area to verify make sure that the switch is operating properly. We have a vent limit switch both on the 80% and the 90%. Again, using your thermocouple thermometer, see what is causing that limit to trip. Then you go down to the blower deck area. Those are automatic reset. If you've got a bad motor and the motor's not turning on, but the furnace is cycling, a lot of that air, if you're in a horizontal position or downflow position, all that heat will collect up there and open up those limits. Now, when a limit opens, if there's nothing wrong with the motor, the board will flash a code up there, up on the board itself, and the blower and the inducer will continue to run. So that kind of gives you an idea of what the limit circuit does. Next question from Don. Is there any kind of factory tour that Nordyne offers? Well, Don, get with your folks at your distributor there, at your company there, and they can get with the local Nordyne rep. And I know we have folks come through the offices all the time in the fall and in the spring, and just get with your local folks there, your local Nordyne folks, and see if they can arrange that for you. We'd love to have you up there, and we always enjoy meeting the folks that come through. Stuart with Stuart's Heating and Air. Will the motor tester do most high SEER motors? Our motor tester will work with only the broad ocean motors. Regal Beloit has their own tester for their motors, and I don't believe we have Regal Beloit motors anymore. We are now with broad ocean motors. So the motor tester that David showed you in the video is used for the high SEER variable speed DC broad ocean motors that we have available for our high efficiency gas furnaces. You'll find those motors on all of our two-stage equipment, some package equipment. I believe the tester will work on the air handlers too. So it can test a wide variety of broad ocean DC motors. And that's what that motor tester is for. If you have a Regal Beloit or some other manufacturers, you'll have to use their tester. This tester will not work with it. Again, if you have any questions, just submit them on the left-hand side of the screen. Starting to slow down a little bit on questions here. So again, if you have any more questions, go ahead and submit them on the left-hand side of the screen. Another question from David. When should the batteries be changed on a thermostat? Well, when I was still out in the field, if I saw a battery-operated thermostat, in most cases, I changed them every fall. I would talk to the homeowner, see if they changed them recently. I used to always keep a little stash of batteries on the work truck and would just go ahead and make that part of my PM. You could ask the homeowner if they got batteries, go ahead and do that for them. But if it's been quite a while, go ahead and change those out. We've all been on those late night calls where a furnace will quit, or during the summer on a hot day when that air conditioner will quit quick, and it'll be as simple as just changing batteries on, on the thermostat, on some of these newer thermostats and higher efficient thermostats. So, it's up to you, but for me, I would do them on my yearly fall PMs and just change them out. And if I was first time at a customer's house for a clean and check or something like that, I'd ask them if they'd changed them out recently. So I hope that answers your question there. There's no really set way of doing it. Next question from John. What two terminals should be tested to see if the thermostat is sending a call for heat? Really, to test the thermostat, what I would do is put the thermostat into heat mode. Like David mentioned, raise the temperature on the thermostat. A few degrees above set point to get a call for heat. Then go down to the furnace itself, take that top door off. If you're not hearing the inducer running or not seeing the red lights going, the first thing I would check is the RNC terminal on the board. You should have 24 volts coming out of that. If you don't, backtrack through, take a look at the inline or the board fuse, make sure that's not open and has failed. If that's okay, then go back to the transformer, check and make sure you're getting 24 volts out of the transformer. From that point on, if your inducer's going or not going, you could check between W and C. Make sure you have 24 volts there. If you don't have 24 volts, make sure you're reading 0 volts from R and W. Make sure that switch inside the thermostat is closed. If it's closed and it's calling for heat, you should read 0 volts between R and W. If you're reading 24 volts, you've got a problem with the wiring coming to the thermostat or the thermostat itself, or in a lot of cases, and a lot of guys will forget, and I've been on this call before on the phones, you haven't let the time delay go through its period of time. Most thermostats have a 5-minute time delay. If you're testing a furnace, you turn off the power, turn it back on. Well, as soon as you apply power, that time delay kicks back in. So if you're testing down at the furnace itself and are using the disconnected by the furnace switch to test the furnace, remember that thermostat may have a 5-minute time delay. So, just keep that in mind. But from R to W, you should read 0 with a call for heat. If you're reading 24 volts, check your wiring, check your thermostat, and then check from W to C and make sure you got 24 volts there. That's kind of the simple way of checking it. If you're not getting any of that, you may want to look at, hey, if the inducer's not running, but I've got that call, check your inducer, make sure you're getting high voltage to the inducer. I know on some of the condensing furnaces, we got a capacitor on there. Make sure the capacitor is not bad. Make sure your connections at the board. Boards do go bad. They're not perfect. So, just check everything out there. You should be, good to go with that. Again, we're kind of winding down on questions here. If you have any more questions, go ahead and submit them. Last question, unless I get one more real quick, from John with the Pell Heating and AC. When is production in Mexico started? I know they've already started now. The furnace line is down there and up and running. We'll slowly be moving some of the other production down there. But I'm already seeing serial numbers come out of the plant down in Mexico. So we're up and running down there, and more products will be produced down there shortly. With that, I think we'll wrap up the question and answer period. I appreciate you all throughout the year, throughout this fall season, watching our Lunch and Learns. We spent a lot of time on troubleshooting pressure switches. I know some of you may have gotten tired of that, but again, that is probably our number one call that comes into tech services during this time of year, is how to troubleshoot and how to diagnose a faulty pressure switch versus something else going on in the furnace. Most of the time it's not the pressure switch that's failed. It's something else going on in the furnace that has failed. So troubleshooting through all that takes up a lot of our time. And we try and get these videos out there to help shorten your time on the phone with us, so you can review these videos and take a look at them and just kind of, as I like to say, re-educate myself, because a lot of times we get focused in on doing other things and we may forget something on a pressure switch circuit. I hope we did good topics for you. Looking forward to next spring. Try and bring in a few more new faces into the Lunch and Learn fold here and some of the quick tips. But we've got some exciting products coming out at the beginning of the year, and we will do a bunch of Lunch and Learns in the springtime on it. We will hit probably heat pumps pretty good in the springtime. We kind of neglected them a little bit this fall, but I wanted to get a lot of the furnace troubleshooting stuff out of there. I appreciate your support on these Lunch and Learns. I know they're one of the, whenever we do a technical Lunch and Learn with the tech department, they're one of the most watched Lunch and Learns out there. So I appreciate your support on it. Have a good winter. Keep in mind, we're really busy on the phone, so be patient with us. If we're trying to get back, we got buried for a couple of weeks there. I think we're getting caught up at this point, and I've got things under control a little bit. So if you got to give us a call, if you're a Nordyne contractor, make sure you give that Nordyne dealer number up front. It'll get you quicker service, just a hint. So make sure you have that Nordyne dealer number. And again, we appreciate your support on these Lunch and Learns. And if you have any Lunch and Learn topics, any ideas, something you'd like to see, shoot me an email at priestley@nordyne.com, and it's PRIESTLEY, D as in Doug, @nordyne.com, or give us a call at 1-800-422-4328. You go through our customer service folks, get a ticket number, and let one of the technicians know. Or if you need to talk to me, let the folks up front know, and they'll get you over to me. So with that, thanks for all your support this fall. We look forward to seeing you this spring. And if you got any ideas, don't forget to get in touch with us and let us know. And maybe your idea will become a lunch and learn one of these days. Thanks for all your support and look forward to seeing you this spring. Thanks.